The overall strategy for business continuity can be summed up in this motto: no surprises. Whatever's happening or could happen, you want to find out about it early, and you want to give yourself plenty of recovery options in the design of your system. Now that's a balance. How much resource and energy do you want to spend on insurance? You might have great recovery systems built into your design, but how do you know they're working? And how do you know that something hasn't changed and those systems haven't quietly stopped working? You need to understand what level of testing and exercise of the recovery systems gives you confidence. And that will help you decide what to include in the design elements and also help shape the human processes that operate and maintain the system.
So business continuity and disaster recovery. Well, again, more quotes here. People don't plan to fail, they fail to plan. In fact, these are the same quotes as before. So let's start with Cloud DNS. It's a boring service, but it's super important because this is the first entryway to any application service on the web. If your DNS is not responding, then your users think you're down and they're going elsewhere. What's also interesting though is Cloud DNS has a 100% uptime guarantee. Out of every service that we could offer you in cloud, this is the one that is the most important actually, which is why we will guarantee that it won't go down. And so we have built-in resiliency to ensure at least your domain names are resolving, because that's the first entryway to getting to your app. Because again, let's reiterate, users only care about data integrity. Right? If the data loses accuracy or accessibility, it's no longer reliable to the system and the users. So therefore, it's lost its integrity. Right? And they always say it takes years to build a reputation and minutes to destroy it. Well, the same thing has to do with the availability and accessibility of the customer data. There are many kinds of failures, including human error, which can lead to data loss. But strategy is best dealt with in depth. So you do defense in depth. You try to minimize any of the potential impact, and especially creating security mechanisms as to how much an individual can potentially cause data loss. So one thing is you sometimes have to save users from themselves, and you have to kind of save the system as administrators from permanently purging something, which is why we recommend a recovery system with lazy deletion. So say a user deletes data, it sits in the trash, and then after 30 days, well, then an application will come and go ahead and delete that. But now it's a soft deletion. So that means that somebody, maybe one of the engineers, could still potentially get in and recover that if the user realizes, hey, it's now gone. And then, of course, it can go to a permanent hard deletion. So trying to tier this out before it officially should go, unless you have an emergency cleanup that occurs, recommend multiple different tiers, which may limit the access on who has this data. But this way, you don't have to completely rely exclusively on backups and archive recovery. And here's always a fun one. The goal isn't backup or archive, it's restore. Nobody ever says, hey, you know what? I've got a fantastic restore strategy. Everybody talks about their backup strategy, but how often do you really test it? I am sure many of us can certainly relate to that. My history, I had a great backup and it looked like it worked until I needed to restore. And when that failed, well, it didn't really matter that I had a backup plan because it didn't work, right? So in this case here, you got to be disciplined. Periodic testing is going to give you a lot more reassurance that you can recover from this. So if you can also automate and script this, so if you can automate the restore from backup, have it running continuously or periodically, this is going to gain confidence that your system is in place and works. So you always want to incorporate recovery testing into your design. It's not fun, right? Everybody loves to build and create things, but resiliency comes from incorporating recovery testing into the design itself. So one way to look at this, and I do come from the storage industry, so this is something we would used to pitch all the time, is when you would have multiple different tiers of backups. Now, some typically are on disk. They're for short periods of time, but they're easily accessible. Another one could be backing up to a disk-to-disk system or some separate storage device, which makes it quickly retrievable. And then you start to get into the archive storage. So this could be nearline or archive, depending on how deep you want it to go. You're lowering your individual cost. And then, of course, because there's a recovery fee of 1 cent for nearline and 5 cents for archive, these are going to be for the longer term storage that you don't expect to ever even have to pull up unless it's some kind of an emergency. So creating kind of a tiered strategy like this is pretty common in the industry and one that's pretty easy to follow and implement. So what about cloud storage, using that for DR? In fact, that's a great solution. I mean, you can store production data on there, but we also have versioning, which will allow you to keep many different copies. So if people overwrite files, you want the version where somebody didn't put in something that offended the CEO or something that was confidential that got leaked out, so that way you can swap back. You can also do life cycle management and actually create an automated process. So what it can do is it can take files as they age off and move them to different tiers of storage that cost less. In fact, it can even delete data after a certain period of time, because at some point, once you're past, say, the 7-year archive mark, you're like, why am I even paying 0.7 cents a gig? Just delete it. So you can create automated policies. And then the next point is you just simply need to enable the recovery and testing to make sure that that data is still available. But the great thing is when you're putting on GCS, that's our responsibility. It's our responsibility to ensure it's available. And it'd be your responsibility to ensure that you have the right version that you want to recover. So going back to process, we need to prepare the team for disasters by using drills. So we have to come up with a plan, right? What can go wrong with your system? What are the plans to address different scenarios? We have to document these particular plans, because we have to pass on this knowledge to the rest of the team. Companies do not scale when only one person holds all of the keys. And so to do this, we have to practice. We've got to bring in new team members. We have to do something somewhat in production. I've actually heard some companies where they would turn down entire data centers and see if they could fail over East or West Coast. It's crazy. I've heard some really insane things, but sometimes that's the only way when you can also accomplish that in a production environment. So you have to understand, you got to balance against the risk of not knowing your system's weaknesses. And how are you going to find out unless you truly put it to the test? Perhaps users are more forgiving if you give them an announcement you're going to do a failover. You don't expect anything, but at least you've set that expectation up front.